All right. In this section, we're going to finish up the chapter. Now we're going to talk about how to speed up the process. But we have to review one thing. Remember, 2 plus 1/3 can be simplified how? Okay, why is it 6/3? Oh, I was saying, so one idea is common denominators. So we have 2/1 is the same thing as we have 6/3 plus 1/3. Now we can combine them since we have a common denominator. We have 6 plus 1. But we're not done. Never leave your answer as an improper fraction. So how many times does 3 go into 7? We could do it this way. 3 goes into 7 twice. 2 times 3 equals 6. Remember, this top number is your answer. That goes out in front. The remainder goes on top. And the denominator always stays the denominator. Okay, you just labored. You did all that stuff to get that answer. Combine the two terms. If we have 2 plus 1/3, then that equals 2 and 1/3. We can also split the numbers of an improper fraction. 3 and 2/5 is equal to 3 plus 2/5. So any form like this can be rewritten as that. First point we have to remember. Another thing we have to remember. Another thing we have to remember. Three times 2 equals 3 plus 3, or 2 plus 2 plus 2. Multiplication is turbo addition. It just does it faster. So now, what if we have this equation? So 3 times 3/4 equals what? Well, let's see. Let's remember. Yes, you guys know this as college students. What are you trying to learn to do? How to teach kids. You can't say, okay, here it is, spit it out. What does this mean? What have we learned so far about this?
So. The,
As we just talked about, and what we've talked about previously.
So, table multiplication is just, addition, but just like
Right.
simplifying. Basically asking us, what, how much is 3 plus, 3/4 plus 3/4 plus 3/4?
You were going to say how much is 3 plus 3? No,
No, I meant like 3/4, but
yeah, it's 3/4, since it happens 3 times. Since we have a common denominator, we just worry about the top.
that's how to explain to them how to not add the denominator, or.
Well, no, that comes in earlier when we talked about adding, subtracting. Remember, you have to build up on what you've taught previously. We taught them, since we have a common denominator, we just take that and write it what the common denominator is. Once we have a common denominator, then you just worry about the top, which is why the bottom can never be negative. Because if there's a minus sign anywhere here, it goes with the equation on top. This is where you reinforce all the rules with them. So 3 plus 3 is 6, plus 3 is 9. It's improper. So 4 goes into 9 2 times. 2 times 4 is 8. So equals 2. 1/4. But the most common answer you'll get when you see this well, no, they're going to say is, well, you did that right here. You took this and just made it close like this. Why can't we do here? How would you answer that?
So I see your point in thinking, I know that multiplication is viewed as just addition. Or
You got me confused there.
Yeah, that we were gonna run.
Remember, if you don't know the answer, don't start talking. You'll confuse the kids.
There's no symbol.
Well, there's multiplication.
Yeah, but it's not the same because like there's a symbol for multiplication right there. But if you wrote it like the way that you did, like 2 + 1/3 equals to that, like there's no symbol, there's no parentheses, there's no multiplication. And if there is a multiplication symbol there, then it can't be that answer.
Ah, so now you have to convince them that there is a difference between these two, that they're not equal. Because this one is a mixed number. How do we know it's a mixed number? As you said, because there's nothing between there. But since there's something between these two, we now know this is a multiplication. It's 3 times 3/4. And then the kids are going to say, well, since it's 3 times, why can't we go 3 times 4 plus 3 over 4? What is that? Where do we see this before? This is the formula for converting mixed numbers to improper fractions. But this is also not right. There's mixed numbers have a coefficient. And then this is not the same as 3 times 3/4. This one is actually 3 plus 3/4. Which is not the same as 3 times 3/4. Because what this one says, it's multiplying. This one says add the number to itself 3 times. Which is where the word times now comes in. This is a times. This is a plus. In order to do plus, we need to have common denominators. So you see, this is going to be one of the most difficult things you're going to teach your kids in elementary school. Simply because the symbols are very important. How you interpret what is said. What is said by the equation tells us what to do. How you interpret what it says. So what is 3 times 3/4? As we said earlier. Yeah. 9/4. So 3 times 3/4 is the same thing as 3/1 times 3/4, which is the top numbers multiplied together and the bottom numbers multiplied together. Easy enough. How about if we're multiplying fractions like this? How would you introduce that to them? Remember, using manipulatives or pictures. How would you do this? Let's use bars. So the first one, 1/2, says we have 2 rows. The 3/4 says we have 4 columns. Now, what this says, only one row is shaded. And it is shaded, shade 3 boxes. So 1/2 times 3/4 equals 1, 2, 3, the 3 shaded ones out of 8 boxes. Which from there, now we can go in the formula. 1 times 3, 2 times 4, same thing. Let's try a bigger one. Try a bigger one. 2/3 times 3/5. Show it to me graphically and show it to me mathematically. All right, so the graphic ones. So we have 3 rows. Five columns. For this one, we know we have 2 rows shaded. And out of those, we have 3 columns shaded. So we'll use those in the opposite direction. We only count the boxes that are shaded in both directions. One, two, three, 5, 6, 7, 8, 10, 11, 12, 14. We have 15 boxes. And there are only 6 of them that are shaded both directions. So 1/2, or sorry, 2/3 times 3/5 is equal to 6/15. Can we simplify? You're not done until you can't do anything else.
Wait, I have a question.
Yes,
How come on the last example we did 1/2 over 3/4 and we only shaded 3 boxes, but on this example we're shading 3 whole columns? Why is it different?
actually, it's not different because we only shaded one. In essence, we did the same thing here. I'm just expanding the process now. We expand 1 row. So let's do these. And we shade 3 columns. We did the same thing here. We have 3 that are double boxed out of 8. Good question. It's just that you're building up the process on how to do it. It's really, yes, it's only 1 row is shaded. Yes, that's that one. And only 3, well, shaded boxes. I should say, oh, 3 columns. Or if you wanted to, you say out of that row, only 3 are shaded. Which would also go in the same logic. Since 2 rows are shaded, out of those 2 rows, 3 boxes of each row are shaded. It's whatever's easiest for the kids to understand. They all mean the same thing. Very good question, though. It's not simplified. Why?
Because the top and bottom can be divided by 30.
Right. They both have 3 in common. So 3 goes into 6. How many times? Twice. And then 3 goes into 15 5 times. That is your answer.
And I also believe that there is another way of solving this one as well, correct?
And there's always more than one way. In mathematics, there's always more than one way. It's just in which order you do the simplification. Which is why I'll give you what the traditional definition of multiplying fractions, and then I'm gonna give you the my modified version of it. So, definition of multiplication of rational numbers. If A over B and C over D are rational numbers, then A over B times C over D equals AC over BD. There's a big problem with that. Problem not always simplified. Not in its lowest terms. So here's my modification. When multiplying fractions, A over B times C over D. First step, reduce. Cancel anything the top and bottom have in common. Then multiply top, oop, top by top, bottom by bottom. Example. 2/3 times 3/5. We see they both have a 3 in common. Get rid of them. Here's another example. It looks like a pain. If you multiply 2 times, can anything on top cancel with anything on the bottom? Yeah. 3 goes into 9 3 times. 5 goes into 15 3 times. 4 goes into 16 4 times. 2 goes into 12 6 times. 6 goes into 6 1 time. So now, since you canceled everything, on the bottom it's 1. 3 times 3 is 9, times 4 is 36. Much easier to do it that way than multiplying first and then cancel. So reduce first. Then multiply. You don't have to worry about anything else after that. You're done. All right. Words used in problems that indicate multiplication. Besides the obvious ones of times, multiply, blah, blah. Of and by. Examples. 2/3 of 9 is. So we have 2/3. This means multiply. 9/1 is. Two times 9, 3 times 1. Can anything on top cancel with anything on the bottom? Yeah, the 3 goes into 9 3 times. Equals 6. You could prove it to them. So 2/3 of 9. I have 9 boxes. There's 9 boxes. I have 2/3, which means I need to do that into groups of 3. Because I have 9 boxes, I want them in groups of 3. Or I'm gonna want 3 total groups. And I want to shade 2 of those groups. So that equals 6. 6 boxes being shaded. Here's a word problem. If 5/6 of the students of a college graduate and 7/11 of the college graduates are female, what is the fraction of the population that are female? Let's look at this. So 5/6 of the student body, so we have 5/6. And we have 7/11. So what this is really saying is that 5/6 of the students that are graduating, 7/11 of those are female. So 7/11, what this thing says is 7/11 of the 5/6 are female. Because we have 5/6 of people graduating. And 7/11 of those are female. So it's 7/11 of the 5/6, which means we have a multiplication. Can anything cancel? No, because 11, 7, and 5 are all prime numbers. 7 times 5 is 35. 6 times 11 is 66. So 35 out of every 66 people graduating are female. Pretty good? Easy? All right. Theorem 6-11 or 6-10, this the identity property of multiplication. Instead of rational numbers, I'm simply going to put fractions. It's easier to write. Identity. If we have a fraction and we multiply it by 1, what does that equal? A over B. Nothing changes. This is true. 2/3 times 1 is equal to 2/3, which means I only have 1 2/3. Multiplication of inverse property of fractions. What is an inverse? For example, if A over B is a fraction, its inverse is B over A. So A over B times its inverse equals 1. Equals the identity. So whenever we say the inverse or the identity, the inverse, to find the inverse, we have to make sure it equals 1. All right, let's look at an example. Yes.
But it also, I'm assuming it doesn't apply with, negative integers as well, correct?
Well, we deal with multiplicative with negative integers. Well, yeah. It has to equal 1. So if we have negative 3/4, the inverse is negative 4/3. Yeah, that's a good question. I'll put that down over here. Also works for negatives. Negative 3/4 times its inverse is equal to 1. Because the negative times the negative cancel, the 3 and the 3 cancel, the 4 and the 4 cancel, so we have 1. What's the multiplicative inverse of 2/3? Right. The multiplicative inverse of 2/3, negative 2/3? Just flip it, yeah. Of 4, what's the multiplicative inverse? Yeah, but 4 is 4/1, so its inverse is 1/4. And D, the multiplicative inverse of 0.
Oh,
Why does it not exist? Well, remember, what is the multiplicative inverse? How do you know if it's multiplicative inverse? If I multiply it to the original, it has to equal what? And 0 doesn't have an inverse, so it doesn't exist. There's none. For each of these, we have negative 2/3. All right, this is 2/3 times 3/2 equals 1. 4 times 1/4 equals 1. How about 6 and 1/2? What would you do first? Because remember, yes, you were correct, but where did 13 come from? You had to first, yeah, so you have to look at what's going on here. The multiplicative inverse of a mixed number put into improper fraction. So we have 6. So it's 6 times 2 and add the top number all over the bottom. 12 plus 1/2. And flip. That equals the multiplicative inverse. Right. Yeah, you're absolutely correct. It was 2/13, but now you have to walk through. Because normally, do we ever just, the first thing you do is switch it to mixed number? Well, why would this be a good thing to do? Is because the multiplicative inverse of an improper fraction will be a proper fraction. So far, so good? All right. Theorem 6-11. The properties of fraction operations. The distributive property. What is distributive property?
How come if we multiply them?
Right. It's the same rule because I never defined what A, X, and Y were. A will be A over B. X will be C over D. And Y will be E over F. That could be integers, that could be fractions, that could be decimals. It doesn't matter. It's the same property. So A over B times C over D plus E over F you do the same thing. The coefficient times each of these. AC times BD plus AE times BF. Whatever's in front of here, multiply to each of those. It's the same property. That's one of them. The second one, the multiplication property of equality for fractions. If A times B equals C times D, then I can multiply the same number to both sides and keep the same number and get the same answer. Why is that important? What it tells us, if you multiply by the same number, you get the same answer. And what this is good for is to get rid of coefficients. Multiplication property of inequalities. For fractions. If A over B is bigger than C over D, and E over F is positive, then if I multiply it to both sides, the E over F to both sides, I keep my inequality. But if A over B is greater than C over D, and my fraction